Today we are doing section 6.3. It's all about the multiplication rules. So our goal is to learn and use the multiplication rule for exponents. You should have a handout for the notes. The goal is missing, so make sure you get that down. We are going to slow things down. Tomorrow is a review, and then the next day we're going to do the STAR test. So this is the last lesson for this week. At some point we will quiz next week, so be aware that's on the horizon. Alright, you do not need to write these down. I just want to take a quick look at these. So, if I was going to write that portion that I just underlined using exponents, how would I do it? X to the third power. Good. Then I have the multiplication symbol. Then the rest of it. How would I write that? X to the fifth power. What if instead I said, hey, write it using 1x? You could write the whole thing as x to the what? Eighth power. Very good. Let's do the same thing down here. I could write it as what? Y to the second times y to the third. What would the whole thing be? Y to the fifth. Good. Alright, getting a little trickier. We have x squared, y squared, times y to the fourth, x to the second, or if I wanted to write it all at once, how many x's do I need? 4, and y to the sixth. Very good. Down here I could write x to the fourth, y to the sixth. If I put it all together, can I make it like xy to the 10th, or what would I do? You can't really combine them, right? There's still 4 x's, there's still 6 y's even when you write it together. Alright, so let's see if we can try to notice the pattern. Here I had x to the third times x to the fifth. I ended up with x to the eighth. Here I had y squared times y to the third. I ended up with y to the fifth. What am I doing with these exponents? Do you notice the pattern? How would 3 and 5 become an 8? How would 2 and 3 become a 5? Yeah, when you are multiplying expressions with the same base, see how these are both x's? You can just add the exponents. That's the shortcut, and it works on all of these problems. The reason we couldn't add here is because they did not have the same base. That's what we're doing today. Do you guys have any questions so far? Alright, here's that actual rule in writing. If you look in your textbook, it would look something like this. A to the m times a to the n equals a to the n plus n. That's just a fancy way of saying when you're multiplying like bases, you can add the exponents. Put a little star down here. This is not the same as like terms. You don't need like terms to multiply. You do need like terms when you're adding or subtracting. So I'm going to throw some like terms problems in here just to see if you remember how to do those. That's what we did yesterday. So if you see pluses and minuses, those are like terms. If it's just multiplication, that's when you add the exponents. So we're going to practice telling them apart and practice how to do each. Any questions so far? Alright, this is in your notes. This is also very similar to a couple problems on your homework, so pay attention here. You'll want to know. How would I do this? X plus x plus x. That would be just 3x, right? You're adding, they're like terms. You add the coefficient in the front. 1 plus 1 plus 1 is 3. How is that different than this problem? Yeah, so this would be what? X to the third power. This is the hardest part of today's lesson, knowing which one is which. When you are adding or subtracting, that's when you're combining like terms and you're adding or subtracting the numbers in the front. When you're multiplying, that's when you're adding the exponents. And these are each x to the first, x to the first, x to the first, 1, 2, and 3. All right, check out the A's. A to the 11th plus A to the 7th. Can you do anything with that? No. Because these are not like terms. These are not like terms. If you have a plus or a minus sign and you don't have like terms, you can't do anything. The only way you can add or subtract is if you have the same variable, same exponent, which we do not. All right, what about back here? Can I do anything back here?
Yes.
What would this be?
A to the 18th.
Very good. Since I'm multiplying back here, you can combine them without them being like terms. You're just adding the exponents. Do you guys see the difference? The hardest part about today is telling the difference. When do you combine like terms? When do you just add exponents? What are your questions? We don't have an exponent up here. When you don't have an exponent, it's kind of like having a 1. So x to the first times x to the 5th would be x to the 6th. Good. Now, I always tell students, when in doubt, write it out, okay? If you don't know what to do, write it out. You have x, 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 x. How many x's is that? Count them up. That's 6, x to the 6th, okay? So if you forget the rule about adding the exponents, don't just give up on the problem. Don't just guess. Write it out. Use your brain. Figure it out, okay? What are your questions so far? All right, here's number 2. So I have y to the 2nd, y to the 5th, y to the 1st, y to the 2nd, all being multiplied. So what do I do with all these exponents? Add them. Careful, don't forget the 1 that's with this one. You do not multiply. We're multiplying these expressions. This is y squared times y to the 5th times y to the 1st times y to the 2nd. But you add the exponents. That's the rule we just learned. And the reason is, well, you have 2 y's here, 5 y's here, 1 y here, 2 y's here. That's a total of 10 y's all being multiplied. It's y times itself 10 times. That's what y to the 10th is. So the trick is to add the exponents. But if you forget the trick, you can just write it out, count up how many you have, and go from there. All right? Here we have x squared y to the 3rd times x to the 5th y to the 2nd. I'm going to have x as my answer. I'm going to have y as my answer. X to the what? 7th power. Y to the 5th power. Very good. All you're doing is adding those exponents. You have a total of 7 y's being multiplied together. X's. That's x to the 7th. You have a total of 5 y's being multiplied together. That's y to the 5th. Questions? All right. Is this the same type of problem? No. Why is this one different? Yeah, this is addition and subtraction. This is not multiplication. Addition and subtraction is when we have to do what? Combine like terms, okay? So I'm going to start with my x squares. I have 1x squared plus 1x squared. 2x squared. Don't change the exponent at all. We're back to like terms, just like yesterday. You're just adding and subtracting the coefficients. Here we have 1x minus 1x minus 1x. So 1 minus 1 is 0. Minus another one is just negative 1x. You don't need the 1 if you don't want it. You can get rid of it. And there you go. I said this before, I'll say it again. The hardest part is trying to remember what rule you're using. Are you combining like terms? Are you adding exponents? That's what you have to be able to distinguish. You combine like terms when you're adding or subtracting. You add the exponents when you're multiplying the expressions. What are your questions? All right, here's number 5. We add the exponents. Let's go in alphabetical order, so we'll start with the u's. So I have u to the first and I have u to the fourth. That's u to the fifth. Very good. When I have long expressions like this, I like to cross them out as I go just to make sure I don't forget about anyone. I have x to the first. I have x to the second. I have x to the ninth. X to the 12th power. Good. I'm going to cross them out. I just have y to the first, right? That's the only place I have a y. So you can just write y or y to the first. That's fine. And then you have z to the 5th, z to the 3rd, z to the 12th.
Z to the 20th.
Z to the 20th. Very good. Raise your hand if there's anything you'd like to discuss from that first page of your notes. Alright, we're going to take this one step further now. This says if you are multiplying expressions with coefficients, remember coefficients are the numbers in the front, you simply multiply the coefficients like normal. So you'll have to write these problems in your notes. The back of the notes, I was having a little trouble with the copy-paste when I got to the back side. It wasn't formatting right, so sorry about that. But you'll need to write these problems, so I'll give you a second. Now, coefficients are just regular old numbers. This is a regular old 4 times a regular old 2. What is 4 times 2? 8. You have a regular sized 8 at the beginning of this problem. For some reason, students want to add those numbers. You add the exponents. That's the trick. 4 and 2 are regular numbers in a regular math problem that are being multiplied like regular, okay? Don't make it harder than it is. Multiply them. Now, the 2 and the 3 are exponents, so follow your rule for exponents. What do we do with the 2 and the 3? Add those together. So this is 8x to the 5th power. What are your questions? Bless you. All right, here's number 7. I'll give you a second to write them down. Those should just be dots. I don't know why they're so big. Those are just multiplication symbols. You can use parentheses if you don't want to go dot crazy. All right, in the front, we have some regular old numbers being multiplied. You might need a calculator. These are starting to get big. What is 2 times 2? Times another 2. Times another 3.
24.
And what's 24 times 3? You might need to do this one off to the side if you didn't grab a calculator. 72. So in the front, I have a 72. All I did was multiply the regular old numbers in the front. Using a calculator if you want, using your head if you want, using a piece of scratch paper if you want. However you get your multiplication answers, Do it in the numbers in the front. Now we'll focus on the exponents. I have x to the first, x to the first, x to the first. That's x to the what? Third. Very good. Y to the first, y to the first. That's y to the second. Very good. Raise your hands if you have some questions. Regular old numbers in the front of these two expressions that are being multiplied are 3 and negative 2. So what do I have in the front of my answer? Negative 6. Just multiply them like normal. Don't get fancy on me. Alright, next I have x to the first, x to the 8th, x to the 9th, and in the back I have y to the 4th, y to the 6th. Y to the 10th. Very good. Alright, I see parentheses. That means I should do the parentheses, but you can't add x and 4, and you can't add x and 4. You have to distribute. Very good. So I'm going to multiply through by a negative 5. Negative 5 times x is negative 5x. Negative 5 times positive 4 is negative 20. So minus 20. Now, usually I write an extra step in there. I'm trying to get away from that since, we've been distributing for a while now. If you still need to write out that extra step, go for it. Okay? In the back, I need to distribute a 2x. What is 2x times x? 2x to the second power. This is like x to the first and x to the first. So multiply the coefficients. 2 times 1 gives us the 2. Add the exponents. 1 plus 1 gives us 2. Alright, and then back here, 2x times 4 is just 8. We're multiplying the normal size numbers, and then the x comes along with it. Next step would be to combine like terms. I always write the largest exponents in the front, so I'm going to do 2x squared. Then I have 2 spots where I have x terms. What is negative 5x plus 8x? Positive 3x. Very good. The signs are different, so you subtract the numbers, keep the sign of the larger number, and then minus 20. So this is kind of a combination of yesterday, chapter 1 with the distributing, what we did today because of the stuff right here. You needed to know your rules for exponents. So this is kind of bringing it all together. I love when that happens. Questions? All right, and here is number 10. Again, kind of a combination of things we already know. What is 3x times 7x? 21x to the second power. Good. When you're multiplying the expressions, you add the exponents. You multiply the regular old numbers in the front. So the 3 times 7 gave us the 21. The x to the first times x to the first gave us x to the second because we added the exponents. Back here you have minus x squared. What is 21x squared minus 1x squared? Do you change the exponents when you're combining like terms? No, so this is just 20x squared. What are your questions?